Welcome. In this session, we will cover how to manage and control network traffic in Azure by using NSG, Network Security Groups. These groups allow you to enforce traffic filtering rules for both inbound and outbound communication, ensuring your Azure resources are properly secured, or at least the communication between them is properly secured. So let's get started. Now, managing inbound, outbound traffic with NSG rules. Well, network security groups, or NSGs, are fundamental tools used to control the inbound and outbound traffic to Azure resources. You can associate NSGs at the network interface, that is NIC, Network Interface Card, which is connected with your machine instance or VM. Or you can also apply this to a subnet level to filter traffic based on specific security requirements. This provides a granular control over which traffic is allowed or denied, helping protecting your resources from unauthorized access. Now, before we move forward, let me tell you one more thing about NSG. NSGs are applied to network interfaces that are NICs or subnets in a VNet, depending on the architecture you are trying to create. So remember that. When I say that you can apply it on, let's say, a network card or subnet, you don't have to apply on both sides. It all depends on the structure you are trying to create. Now let's move to inbound rules. Well, inbound rules define the traffic that is allowed to reach your Azure resources. For example, you can allow HTTP traffic on port 80 for web servers, or you can allow SSH traffic on port 22 for remote management of your Linux virtual machines. Each inbound rule specifies the following thing. Well, the first thing they actually specify is source. Example, a particular IP address from where the request is coming in, or a whole virtual network range, or you can also use a wildcard to tell Azure that, hey, source can be anything. So for that, you can put a star. The next thing which inbound rule define is port. That is HTTP, that is port number 80, SSH on port 22, or RDP on port 3389, I think, and so many other protocols like TCP, UDP, or both. Then the rule defines action, that is allow or deny. So these things are defined in your rule. Let's talk about outbound rules. It's the exact opposite. Outbound rules control the traffic that is allowed or denied to leave a resource. Leave to where? To outside network. For example, restricting outbound internet access from a resource to limit exposure to public domain, or allowing outbound traffic to other Azure services, such as a machine which wants to talk with Azure SQL or Azure Storage. That is also outbound transmission. Now, outbound rules help ensure that your resources are not unintentionally sending data to external locations, which could be very risky for your security. But remember, outbound does not mean always that the machine wants to go to public domain or internet. No. Even traffic which wants to go from one network to other network is still considered outbound traffic. You can control that with NSG. Then you have your priority. So rule prioritization. Well, here NSG rules are evaluated in a priority order, with the lowest number rule having the highest priority. For example, a rule with priority 100 will be evaluated before a rule with priority 200. If two rules conflict, the first matching rule in terms of the priority will be applied. It is crucial to organize and structure your rules in such a way that you minimize conflicts and ensure the correct flow of traffic. Remember, give some gap between priorities as well. If the first rule have priority 100, the next should be 110 or 150 or even 200. Why? Because in the future, if you want to add more rules in between the previous rules, giving gaps will make the process much easier. Otherwise, if there is no gap, you may have to shunt all the rules one step further. So that will bring too much headache and overhead in the manageability. The next is your default rules. Well, NSG come with few default rules which you cannot delete that provide baseline security. These rules include allowing inbound traffic from Azure load balancer or denying all inbound traffic from the internet by default, allowing all outbound traffic to internet unless specifically restricted. These rules are automatically applied when you create a new NSG, but you can customize or replace them with your own rule, which will trump the default rules. These default rules are always visible whenever you create an NSG and you go and you check it out. Let's go to our lab and check how easy it is to apply NSG. We will create NSG, apply it, and we will also test some inbound request, how we are trying to allow the request, how we can actually deny it.
All right, now let's check how to deploy NSG, Network Security Group. For this demo, I need a subject, right? I need a test VM. I already have one. So I will show you my structure. I have a resource group. Inside my resource group, I have a machine. And this machine also have a public IP. So keep things very simple. Through this public IP, I want to connect with this machine. Now, if a machine have a public IP, and that actually means this machine is kind of exposed, not a good thing. But at least we can put NSG on top. So let's try to do that. But before that, let me copy this public IP and let's try to connect with this machine. So I will go to my sandbox and RDP. I copy this public IP and paste it here. Let's see what happens. I cannot connect because no ports are open. Yes, I can go to this public IP, but there will be no response coming from the other side. So let's deploy the NSG to open the ports. There are two ways. Basically, you can just go ahead and create an NSG, configure it, and then assign it. Or you can go to the machine, click on the machine, go to networking, network setting, and then assign it. No port rules to display because there is no NSG, so there will be no ports open. Both way will actually work. And then there are two levels where you can assign NSG. You can assign it to the network card, or you can also go to the network and assign NSG to the subnet level. So both levels actually have their own significance. They have their own structure. If you apply it on the subnet, then obviously all the machine inside this subnet will inherit the NSG rules. So everything will be open. But you can also actually apply it on a subnet level and then also on the network card level, NIC level. In that case, you have to make sure that line of sight is created properly. That means if your subnet level is blocking something and your network card level is allowing that request, it will not work. Either both have to block or one actually have to block or the other one have to actually allow. It depends on the configuration. So when I say one have to block, I mean let's say your subnet is allowing port 80, that is HTTP traffic, but you want one machine to deny this connection. So you can go to the machine level and you can deny this connection. This way, all the other machines will just allow HTTP, one machine will deny. But if you want the machine to also allow HTTP, then you have to open this port on both sides, subnet level as well as network card level. So that was the theory part. Let's see how it actually works. So I will go to the NSG and let's create one. I will call it demo NSG01. I will do it in Canada Central, no need for tags for this demo, and create it. So that's it. This is how easy it is to create NSG. But now we have to configure it and then assign it. So let's go to the NSG itself. And over here, we are configuring the inbound request, which wants to connect with the machine over here. So we have to add a rule on inbound. If you want to change the outbound, means outgoing request, then you will add a rule over here. Now, these are the default rules. You can even hide the default rules, but now you can see that there is no custom rule here. So I can add one. Source, at this point, I will just say any. And the request can come from any port. I don't care. The star simply means it's a wild card, which means that the request can come from any port. Destination any means it can go to any machine inside the subnet. Now, service. Which service you want to allow? In this case, I want to allow RDP because I want to connect with the machine. Do you want to allow it? Yes. And the priority, I will just say 1000 because I like to keep some room on top and at the bottom. Plus, I also put some room between two rules. Maybe in the future you want to add more rules. So if there is no room, then you may have to adjust multiple rules one by one. That will be difficult to do, right? So I always put some gap and add. All right, so the rule is now added. Now, do you want to apply this on the network card or subnet? Let's apply it on the network card. I only have one machine, so I will only see one network card. Now the NSG is associated with my network card, and the network card is connected to my machine. Now let's go back to the machine and check. Network settings, go down, still nothing there. But don't worry, whenever you make a change, it can take some time to actually reflect. Here we go. NSG is connected and this port is open and the rule actually allows the request to come in. Can we now test it? Let's try. And even this might not work immediately. So I just applied this rule. You may have to wait for a minute or two. All right. Let's connect. And as you can see, we are connected with the machine. So that is your NSG. All right, now let's check how to manage NSG. So I have a machine and the NSG is already connected with the network card. And in that NSG, there is an inbound rule defined to allow RDP connection. Okay. And I'm also connected with the machine via RDP. So I will wait for this machine to log in properly. Now I will do two things. First, I will deploy one more NSG, but on the subnet level. Let's create one more NSG. NSG02. and create. All right. And now in this NSG, I also have to add the same rule. So let's add that. I'm going to allow RDP and 1000. Click add. Now I will assign this NSG to the subnet level. This will go to the subnet. Done. Now once this is assigned, the line of sight for RDP connection is still there. It will go through the subnet and the subnet will actually allow it because the NSG have the rule for RDP to actually pass through. Then we'll go to the machine and the machine also have the NSG which allows RDP. So the line of sight is there. And as we can see, we have the connection still working. Now, just to test the another service, I'm just going to deploy IIS on this machine. Remember, this is just for testing. So now this machine, after this service is installed, will act like a web server. So I'm going to install IIS, Internet Information System. Service, sorry. Let this configuration finish. All right, it is done. And now this service is not running on port 3389. It's running on port 80. I can actually sign out. I don't want to RDP anymore. So let me sign out. Remember, this is my sandbox. This is acting like a normal machine on public domain. So if I go to my browser and connect with this machine's public IP, I'll copy this and paste it over here. My request is going through port 80 this time. And the NSGs are not configured to allow any requests coming from port 80. So can I actually change it? Yes, I have to add the rule. So let's add the rule at network card level. The NSG at network card here. Let's add a rule. This time service will be HTTP coming from port 80. Done. Let's try it. I'm still not able to connect. Why? Remember, line of sight. There is one more NSG actually blocking my connection, and that is at the subnet level. I have to add the rule over here as well. So let's do that. Done. Now let's go ahead and try it. Remember, I just added it, so I may have to wait for a minute. And here we go. So we can connect with the web server on that infrastructure on my machine. So both NSGs are actually allowing the request to pass through. So that is how you configure NSG. Now, let's try something else. Let's try to remove or to add a new machine. So I'm just going to add a new machine. And with this machine, I will not attach any NSG. So let's see what happens. So it will be a new machine, VM02, just for testing, VM02. Okay, I don't need any security, high availability not required, just a Windows 10 machine. I will create a normal local admin account. And over here, I will say ports open. Yes, I want to open RDP, but I will not deploy any NSG. Next. over here, I will just keep it standard just to save some money, not for this demo. And this is important. Do I need a public IP? Yes, to connect with this machine, but I don't need any NSG, so say none. Okay. And it will be connected to my machine, VNet. So let's deploy this machine. Now think about it. I have not created any extra NSG for this machine. There will be no NSG. But can we still connect with this machine? The answer is yes, you can still RDP to this machine because there is one NSG deployed at subnet level. So that NSG will get inherited over this machine. So the subnet level NSG actually do allow HTTP and RDP. So it should work. So that will be the test. I will just wait for the deployment to complete. All right, deployment is done. Let's go to my machine number 2 and click on network settings and see if there is any NSG. Here we go. So this NSG number 2 is being inherited from the subnet. So it is attached to a subnet, still allowing RDP and also HTTP. I cannot see it here, but it is there. So let's try to connect with this machine. This is a new public IP. I can minimize it and paste it. Here we go. We can actually connect it. So you can just put the credentials. Perfect. So this is how you configure NSGs, guys.
Welcome back from the lab. Now I know that you are pretty comfortable with NSG. That was easy, right? Yes, it is that easy to actually create NSG and apply it. The only complex thing is when you have a lot of resource which you want to protect and you want to control the traffic, then you may have to juggle with a lot of rules that may look complicated for someone who's new to this setup. But remember, it's the same easy steps performed multiple times. In summary, network security group NSGs are powerful tool for managing network traffic in Azure. By defining inbound and outbound rules, you can control the traffic to and from your resources, ensuring they are securely configured. Inbound rules determine what external traffic is allowed to reach to your resources. Outbound rules control the traffic that leaves your resources to next network. Now, prioritizing your rule based on your security needs, an NSG will evaluate them in the order, where lower number have the higher priority. It starts from 100. Now, remember that default rules are applied initially, but you can tailor them to suit your organization's requirement. By using NSGs effectively, you can manage network security and protect your Azure resources from unwanted traffic and vulnerabilities. So that's it for this episode. Thank you for joining in. I will see you in the next episode. Take care.